So what I would like to do, though, right now is maybe just pivot a little bit from what we've talked about so far. And I want to pivot in a few different ways. One is that what I'm going to be talking about with you today is really looking much farther inland than we've talked about thus far. We're thinking about the issues of the movement of salts upslope far into the coastal plain. I want you to think a little bit longer term and larger scale, so the sort of cumulative impact of many different droughts and hurricanes, all of which load salts into the coastal plain and change the way that it works. And I want you to think about chemical movement, not pollutants coming from hog farms and fertilized fields into the coast, but think of those marine salts moving inland into the coastal plain. And so we have this exchange of chemicals that is bidirectional. So Lee already talked this morning about a lot of the pollutants that are coming from the land to the sea. Marine salts aren't pollutants, but they do fundamentally change the sort of set of rules for freshwater systems. And I'm a biogeochemist, but I'm not going to show you any element cycles today, don't worry. But I'm going to teach you two things about chemistry that you know already. You know when you go to the beach and you have to keep cleaning off your sunglasses because all these salt crystals keep forming on them? So I just want you to think about that residual of salt constantly being left behind every time salt water hits a soil or a tree leaf, right? So every time we get water moving from the ocean into the coast, either because of droughts and wind tides or because of storm surges, it's leaving behind a residue of salt. So we've been talking mostly about just water quantity issues, lots and lots of water moving and causing damage, but the salts in those waters getting left behind is another part of the legacy of coastal change. The other lesson that I want you to think about is anytime you've gone into a salt marsh, it has that characteristic and wonderful rotten egg smell, right? And that is reduced sulfides. Once you get a system that is sulfidic, that has that rotten egg smell, most plants can't live there. There's only a very specialized number of vascular plants that can live in a salt marsh. And so as our coastal plain, freshwater wetlands, and farm fields get enough marine salts, eventually they're going to shift to becoming sulfidic systems. And at that point, you've reached a threshold where it's really hard to go back. So I'm really thinking about the movement of marine salts into the coastal plain and the consequences for forests and farms throughout this large area of what is mostly a rural landscape. We've mostly been talking about cities and settlements and coastal development, but I'm really interested in sort of the vast rest of the coastal plain. And I'm not alone in this. I'm sort of currently working in a number of synthesis groups with hundreds of scientists up and down the entire East Coast and Gulf Coast, really trying to ask what's going to happen to the ecosystems and communities of the eastern coastal plain over the next century. We think about sea level rise as this gradual change. I'm just showing you this graph from the beautiful NOAA. If you don't already know this webpage, it's great. The NOAA Sea Level Rise Viewer, you can sort of play with changes in mean high water. This is the current mean high water mark. And then I'm just showing you here what it looks like in sort of the low end and the high end of, the low end and the high end of projected sea level rise over the next century. So, and I'm sort of zooming into the area of the landscape in which I spend most of my time, which is this little low peninsula here between the Albemarle and Pamlico Sound. So I like to call it the Pamlico Peninsula, but it's hard to say fast. And you can see that for sure, one of the things that's going to happen in the next 100 years in this landscape is we are going to lose land to the sea. The amount of land that we're going to lose is really uncertain, but we're definitely going to lose some land. The other thing that's really uncertain is the land that is adjacent to that. What's it going to be like? What are those habitats going to be like? And I will say, we don't have to wait. I think we still talk about sea level rise as the thing that's happening in the future. We already have a huge amount of this landscape that is already subjected to very frequent recurrent floods. And so this is another really beautiful NOAA data visualization page, the Coastal Flood Exposure Mapper. The red here is showing you areas that are currently subject to tidal flooding. So already experiencing really frequent recurrent or nuisance flooding. And many of you live or spend time in places on the North Atlantic coast that are red, and you're familiar with the problems that causes. That means it's a really low-lying place. It's really closely and easily connected to the ocean. So I want you to think about that as a place that is liable to be exposed to marine salts anytime there is either a drought or a hurricane. So we don't have to wait. And of course, that's just regular flooding. We can think about hurricanes as really extreme examples of this. So again, the same mapping tool looking at a Category 1 hurricane versus a Category 5 hurricane for the Carolina coast. All the places that are highlighted there are places that are going to be exposed or could be exposed to marine salts during a tidal surge. And of course, this happens not infrequently, and we're expecting to happen more frequently, or at least more in a more extreme hurricanes in the future. This is just the hurricane tracks between 1851 and 2016. This is a great slide to use for any talk for people who are not from North Carolina. We are in the hit zone very clearly, right? We're going to be hit, and we have been hit many times. We will be hit many more. So just to sort of bring that down into scale and think about what does that mean, I'm now going to zoom into Goose Creek State Park on the southern side of the Palomar Peninsula and show you what happened during Hurricane Irene. A huge amount of rainfall. This hurricane came in. There was a very big storm surge. Goose Creek had a levee put in to try to protect some of the forested areas. And the storm surge was high enough that marine salts overlapped the levee and left behind this huge amount of salt. I just want to direct your attention to that blue line here. We're getting salinities of 3 ppt. The sound is 5 to 20. So we're getting brackish water that persists, if you look at the x-axis, for over a year and a half. So it takes about a year and a half for the marine salts that are loaded during a single hurricane event to actually escape from that forest. You can imagine what that's doing to the plants and the organisms that are trying to live in those soils. So hurricanes are one source of this. Kind of counterintuitively, so are droughts. So this is my long-term study site on the northern part of the Pamela Marl, where we were studying an agricultural field that was being converted into a forested wetland. And this is data showing what the surface water canal was looking like at the inflow of that in the droughts of 2007 and 2008. We see brackish water coming in during these extreme drought events. And in both of those years, or at least in one of those years, the end of that event was due to a hurricane. One of those was Hurricane Irene, I believe. And so both, when you have droughts and you have low-lying landscapes, winds pushing these salt waters up from the ocean in far inland. And this is coming in through the canal and irrigation systems. So we're also seeing an increase in the intensity and the duration of droughts throughout the southeastern coastal plain. So again, both increased extreme events in terms of both hurricanes and droughts are both likely to load salts into our landscape. It's not just the climate change issue, it's also an issue of the way that we have modified our coastal landscape. So now I'm showing you the same landscape, but all of that gray there are drainage ditches and canals. So we have massively modified the way water moves through this landscape in order to move water off so we can farm on what would otherwise be flooded landscapes. And that infrastructure also enhances the vulnerability of much of the interior of the coastal plain to connections to the sea. And that's not, so we've built this stuff to move water off the landscape, but it also provides a really easy conduit for salts to move upslope. This is something we've been working on for the last 5 years, is to try to create models to predict that. This was led by Avi Bhattachan, who was a postdoc at NC State. I'm just showing you the saltwater vulnerable parts of a little piece of the peninsula. In red are the areas that are vulnerable. If you don't include the ditches and canals, and then if you do include the ditches and the canals, you can see that that really expands the part of that landscape that's red. And now I'll just make a color difference map that shows you all of the places that have enhanced vulnerability as a result of infrastructure. So this is both, I think, upsetting, but also has a lot of potential for humans have an enormous potential to impact the way water moves through this landscape. We already do. We have water control structures and pumps and floodgates that can actually change the way water moves through the landscape. But if we decide, for instance, to abandon a lot of agriculture as fields become salty as a result of climate change or changing economies, and we don't think about how we manage this water, we're going to have a really big problem on our hands. So in my world of ecosystem scientists, a lot of people spend a lot of time thinking about gradual sea level rise. There's been far less attention, although that is changing, and thinking about the episodic saltwater intrusion that is already happening and really precedes these climate change impacts. So we're kind of calling it the leading edge of climate change, where you have this highly heterogeneous exposure. You have both flood and drought events that move salts in the landscape, and that's interacting with a landscape that itself is really altered by both land use and land use legacies. Saltwater is a complex mixture. It kills things both because it's salty for things that are fresh, that need fresh water, but also because of that sulfate that it provides. And this is the only complicated graph I'm going to show you, but I want you to think about the idea that what we're seeing is this cumulative impact. Every time there's an event that brings salt in, it leaves behind sort of a bank of salt. And the next event brings in more, and the next event brings in more. So you have sort of this pulsed, episodic, cumulative impact that over time sort of inexorably moves you towards a freshwater system becoming a saltwater system, or an active farm field becoming a field that's too salty to grow traditional crops. So the impact of this, of course, we're already seeing it. Many of you already see eroding coastal margins. You go to the coast and you see cypress tree stumps 10 feet out away from the coast. We're losing land. We're also seeing that happen inland. I'm just going to show you a few pictures. Everybody knows that happens on the margins. I've got a picture from Palmetto Pear Tree and from Alligator Wildlife Refuge out on the Palmetto Marl. But it also happens in the interior. So there's an enormous section of ghost forest right along the inland coastal waterway, a really obvious route that's bringing both high water and salts in the landscape. So one of the things we're trying to do is actually map how much has already changed. So I'm just going to show you kind of a general idea how we're doing that. This is a little tiny piece of Alligator Wildlife Refuge focused on Point Peter Road. Anybody ever been there? Great place to see Lost Coast. And so we can look over time through imagery between 1985 and 2019, and we can track the changes in this landscape over time, both how much land has been lost and also how much is forested versus herbaceous cover. So just for this one piece of the landscape, we can see that we've lost land. Open water has expanded. There's more open water as a result of the loss of land. We see that forested wetlands have been lost. We're losing trees, basically, and we're bringing in a marsh. But the marsh isn't fully compensating because we're also losing land. I'm just showing you we're doing this for a piece. The idea is we're going to be doing this from Cape Cod to Texas over the course of the next 2 years to try to estimate how much ghost forest has been formed the last 20 years. And more importantly, can we start to predict what parts of our forest are vulnerable to these changes moving forward? So I would love to talk to people about that, and we're especially interested in people who have experienced that change on their properties or in places that they know so we can have ground truth data. One of the things that's really interesting is that, as I said, this is often a pulsed effect, so you can see both extreme change and then some evidence of recovery in some of these areas, and we're interested in that as well. Which parts of our forest are being lost forever, which are being damaged and then regrowing? I think you're going to see both. So that's the ghost forest side of this. Of course, the other huge part of our rural landscapes on the coastal plain are agricultural landscapes. I'm showing you fertilized cropland. You see this beautiful dark green band up and down the coastal plain. And saltwater intrusion is becoming an issue for many farmers. It's probably best studied in the Delmarva so far, but we are finding many farmers on our coastal plain who are experiencing a loss of land or land they're having to move into out of production as a result of salinization. Alex Manda at East Carolina has been doing some really nice work on this. There was a really great story in the Washington Post about farmers in coastal North Carolina who were basically saying we are not going to be able to do this for much longer if this trend continues. And so I think that's another interesting thing is trying to actually estimate how many farms are being lost to saltwater intrusion. What can we do to help protect that? In the Delmarva, they're doing a lot of beautiful work moving towards salt-tolerant crops as a sort of a transition or adaptation towards the next stage. And I think that's a really interesting an issue. When saltwater gets onto farms or when saltwater gets into really any soil, it extracts nutrients. So if I'm a biogeochemist, spend a lot of time measuring the nutrient content of soils. The way I do that is I take a soil sample, I bring it back to the lab, and I add salt. And that strips all the nitrogen out of the soil, and then I can measure how much is there. Same thing happens when ocean water hits a fertilized farm field or an old fertilized farm field that's being recovered into a restored wetland. It also extracts nutrients. So we've done a lot of work showing that as salt water comes onto landscapes, it extracts soil nutrients, and then that contributes to coastal pollution. So we've been seeing this picture a lot of times like the poster child of coastal pollution, but I want you to imagine that you have a drought with salty surface waters on a lot of fertilized landscape followed by a hurricane, and you have sort of the perfect whiplash weather situation to move an enormous amount of nutrients from our soils, both our fertilized soils and our natural soils, out into our coastal plain. And that's part of the reason why we see massive algal blooms following hurricane events. And it's not just the hog lagoons and the sewage, it's also the incredible amount of the landscape here that is covered in fertilizers that are susceptible to saltwater extraction. So what are we going to do about it? That's why I'm excited to be in a room with a whole bunch of people thinking about that. It's a wicked problem, right? We actually have an enormous amount of ability to change the future of this landscape, either through creative adaptation or through unintentional and unavoidable abandonment. And I think we're looking at some really, really different scenarios in the next 100 years for this landscape. I showed you this idea of vulnerability, impact, and responsive as if it was a sort of one-direction thing, but in reality, what we decide to do now is going to really determine our vulnerability over the next set of decades. And so I think that there's a lot of opportunities here. Do I have time? I'm going to close with a 1-minute clip from a 10-minute video that we made with Science Friday earlier this year. And I put the link there, and I hope you'll take the chance to watch the whole thing. This is done by Luke Groskin, and he did a great job, I think. We'll see if we get sound. Oh, wait.
As if these forests and
do you mind if I just start that over, guys?
Then we might be in for some really rocky surprises in a few decades.
I think humans can have a huge impact on both whether new ghost forests develop, whether current ghost forests expand, and also what happens now once a ghost forest exists on the landscape. Do we leave them? Could we manage them in a way that we might actually move more rapidly into a sort of a salt marsh ecosystem? I think there's a lot of interesting decisions that we could begin to make. They're not going to be forests in those places probably again, but they might be something equally interesting and beautiful. That's not right, Emmanuel. Just so anyway, it's a whole 10-minute video about sort of this issue, and I encourage you to watch it, and I'd love to talk more about it with everyone here. Thanks.
Thank you.